First problem asks us to solve g equals RT for r. When we look at where r is in the problem, it's on this side being multiplied by t. To undo that multiplication, we're going to divide each side by t. Divide by t here, divide by t here. That'll get rid of the t's and just leave me with r as being equal to g divided by t. When we want to solve b equals t over c for b, sorry, I think that's probably the wrong equation for c, sorry. In this situation, when we want to solve for c, we're going to first multiply both sides by c, because really this is t divided by c that we have here. So when I multiply by c, these c's will go away and just leave me with t. So I have cb equals t. I can now solve for c by dividing by b, dividing by b. These b's will go away and just leave me with c equals t divided by b. When I go to solve e equals t minus h for h, two different ways I can look at this. Either I can move this t, then deal with this negative, or I can move the h and then move the e. I'm going to choose the move the h, move the e method, but either way would get me to the same answer. So I'm going to start by saying let me add h to each side. That gives me e plus h equals t. If I then subtract e from each side, on the left-hand side I just have h. On the right-hand side I have t minus e. I could have gotten there by saying instead e minus t by moving this t and then multiplying by a negative 1. So if I had just kept this negative h on this side, move this t to there, I would have an equation that said negative h equals e minus t. If you compare that equation to our equation, it's really the same thing with just all the signs changed. If I take this negative h and change the sign, it would become a positive h. If I took this negative t and changed the sign, it would become a positive t. And if I took this positive e and changed the sign, it would become a negative e. So really I can move from here to here by multiplying this equation by negative 1. I think it's easier to see this way, but either is a valid way to arrive at the answer. Problem 4 asks me to solve for k and w equals slk. Currently k is being multiplied by s and being multiplied by l. To undo multiplication, I'm going to do division. This s and this l will go away and just leave me with k by itself. It equals the w that was on top divided by the sl that we divided each side by. In problem 5, we're asked to solve for L in the equation z equals 2bl minus 5. I'm going to start by moving this 5 plus 5 plus 5. That gives me z plus 5 equals 2bl. I now want L alone, so I'm going to divide by the things that are being multiplied by L. 2 times b times L means 2 times b is what's being multiplied. This 2 and this b will go away to just leave me with L. L is going to be equal to z plus 5, all being divided by 2b. I'd say this is about as complicated as it gets in here. I understand that I'm doing a lot of things quickly here, so to go back and break down what I did, I started by looking for where the L was. I saw that it's being multiplied and then something's being subtracted from it. As long as it's not a case where the subtraction's occurring in parentheses, like if it was like that, it means that subtraction or addition is the outermost thing occurring, and I should get rid of that before any multiplication or division. So to get rid of this subtracting 5, I added 5 to each side. That's how I got z plus 5 over here, and I now had 2bl on the right by itself. That makes it a problem like number 4, where I'm just going to divide by the two things that are being multiplied by. The key distinction here is instead of just dividing one term, I'm dividing two terms being added. So I want to make sure that both those terms are shown as being divided by the 2b. In problem 6, I'm asked to find m by itself within the equation j equals am plus f. The way I'm going to do it is I'm first going to move the addition or subtraction that's happening outside of the m. So positive f, I'm going to move by subtracting f from each side. This plus f and minus f will undo each other. On this side, I have j minus f equals am. When I'm solving this for m, a being multiplied by m can be solved by dividing by what's in front of the m, specifically this a. That'll go away and just leave me with m, which equals j minus f being divided by a. J minus f being divided by a. In problem 7, we have s equals 4ah, and we're asked to solve it for h. Again, we look at what's happening to h. We find it on this side of the equation, being multiplied by 4 and being multiplied by a. To undo multiplication, we're going to do division. So I'm going to divide by 4a. What I do to the right side, I have to do to the left side. These 4's will go away, these a's will go away, and just leave me with h. On the other side, I'm going to have s divided by 4a. Here I'm trying to solve for b. I have h equals 2o minus 3v. In order to get v by itself, I can see it one of two ways. Either I can see it as the v is going to move over here and become positive, or I can leave it here, move the 20, and then divide by what's in front of the v, including the negative. I'm going to choose to do it the opposite of the way I did this time. So I'm going to leave the v as negative on this side and move the 2o. So minus 2o minus 2o. That gives me h minus 2o equals negative 3v. I'm going to divide by what's in front of the v, negative 3. That's how I get my final answer. V equals h minus 2o over negative 3. If I'd done it the other way, I would have had it as 20 minus h over a positive 3, which again may not look like the same thing, but mathematically is if I just multiplied top and bottom by negative 1. For problem number 9, I'm asked to solve for e. In this case, even though this is addition that we've been using first as something to move things, the addition is happening inside the parentheses. That kind of protects it within PEMDAS, or please excuse my dear Aunt Sally to say, that takes precedence over multiplication. So this b that's being multiplied by this whole parentheses needs to be dealt with first by division before I can then get rid of this g by subtraction. So I'm going to divide each side by b, divide by b. That gives me g plus e equals u over b. So u over b equals g plus e. I was asked to get e by itself. It's currently being added to a positive g. To get rid of that positive g, I'm going to subtract g here, subtract g here. That means that these go away and just leave me with e. To be clear, I wasn't subtracting this from the denominator. Maybe I should just write it as a more general minus g. This still stays as a division problem, u over b, but the minus g is just by itself off to the side. That minus g, the g was inside the parentheses, so it wasn't a term that was impacted by dividing by that b. This part where we divided by the b got rid of what was there. So this one's, again, a little bit more confusing than some of the others, but it all goes back to order of operations and basically making sure that I'm working from the outside in, where instead of going PEMDAS, where parentheses are most important on down, you basically work up, where if you see subtraction, you get rid of that first, on until you get to the parentheses, which is the last thing that I deal with. For problem 10, I have y plus r equals o plus p, and we're asked to solve for p. Here I see p on this side, nothing's being multiplied by it, nothing's being subtracted. The only thing that's happening is o is being added to it. To undo a positive o on this side, I'm going to subtract an o minus o. These will go away and just leave me with a positive p. The y can stay, plus r can stay, and then this just says minus o. So my final answer would be P equals y plus r minus